Okay, so because it's more, this is more important, I'm going to, instead of going 2 sections a day, we're only going to go 1 section a day. In chapter 8, which is, good for you guys. So we're kind of going to slow the pace. You're still going to have the same amount of homework because I'm going to give you a different, you're going to have the homework associated from here, and I'm going to give you something else. So you're still going to have the same amount of homework, but you'll be on only 1 section worth of stuff, okay? Where are we at? Let's make sure I got this. I do not. Okay, all right, so let's go. 8.1, relations and functions. 8.1, relations and functions. Okay, so we are on page 401. Page 401. Alligators. The table below shows the ages and lengths of 5 alligators. So they went to, I don't know where, Florida, I'm guessing somewhere Florida. They caught 5 alligators, and they have data that shows the age of the alligator versus the length. Okay. I'm going to assume there's some way to determine what their age is, because it's the only way to know. And they measured the length. And what do you see there? And in general, what do you see? Is there a trend as they get older? What is the trend? They get longer, right? Which makes sense, right? The older they are, they get longer, right? It's the older you guys get, you get taller, right? Okay, it's kind of the same thing, right? You can represent the relationship between age and length using the ordered pairs X and Y. So we're going to call the age X. We're going to call the length Y. Okay? So basically, you have the input and you have an output. So you input an age, you get an output of the length. Okay? So there are several ways to notate that. So we're using X and Y, okay, and we're calling this the input, and we're calling this the output. Okay. Look there, there's also a thing called domain and a range. So a domain is all of the possible inputs. Okay. Where the range would be all of the possible outputs. Okay. So go back to that. If you go back to the alligators there, what is my domain? Alligators there. 2, 4, 5, 7, right? 2, 4, 5, 7. There's 4 of them, right? There's 4 possible inputs. 2, 4, 5, and 7, correct? Okay. What is the range? Lysandra, what is the range?
I guess. Oh, all of them?
All of the possible outputs.
I guess 32, 59, 65, 69, 96.
Correct. Okay, so those are the possible outputs. So that would be the range. In other words, all of the possible, the domain would be associated with the inputs, whereas the range would be associated with the outputs. Okay. You will learn later on that this is called the independent variable X And this is the dependent variable. And that is because, again, you input, when you put in an X, you get a Y. Right? We're not interested in putting in the length and finding out how old it is. We're interested in putting in the age and finding out what the length is. Okay? All right. Okay, so that's that. A ordered pair forms a relation. A relation is a pairing of numbers in one set, called the domain, with numbers in another set called the range. So we're pairing for each domain input, within each input, there's a output. Okay. So let's go to example number 1. Identify the domain and the range of the relation given above. We already did that. B, identify the domain and the range of the relationship by the table below, which shows one alligator's length at different ages. Okay, so for this one, for the one in the book, what would be my domain? Cooper? The domain is all the possible inputs, all the possible X's there. So what would be my domain there?
2, 4, 5, 5, and 7.
Okay, we're looking at the one, example 1, where it says ages.
1, 2, 3.
1, 2, 3, 4, 5, right? Okay, all right, good. The range, Logan, what's the range?
23, 36, 47, 61, 73.
Okay, good, cool. So that's good. Let's flip the page. Representing a relation. So to represent the relation, we represent it as a graph or as a mapping diagram. Okay, a mapping diagram is the easier one, where you just write down the ones and then you just map it across. So let's do that first. Okay, that's the easy part. So we'll do that one first. So I have -1, 1. -1, 1. I have 2, 0, 3, 1. And then 3, 2, 4, 5. Okay, so let's go ahead and map it first. All of the inputs, all of the X's will be -1, 2, 3, 3, and 4. These are all the possible X's, the possible outputs. My range, 1, 0, 1 I already have, 2, and 5. Okay, so we have all the inputs. We have all the outputs. Let's go ahead and map them. So this guy, -1 to 1. So now from -1, I go to 1, 2 to 0. That's easy. 3 to 1. That's 3 to 1. I have 3 to 2. And then I have 4 to 5. Can you see how I did that? Pretty simple. Nothing much going on there, right? So the mapping part is easy. Okay. So now let's go ahead and graph it. It also asks us to graph it. So let's go ahead and graph it. So this is where we would put the X and the Y axis, right? X and the Y axis. So this is the X axis, this is the Y axis. So my first one, when X is -1, because the first one is always X, right? The second one is a Y. So I get -1 and 1. Okay. So this would be -1 and 1. 2 and 0, so it'd be 2 and then 0. X, y is 0, so this is 2 and 0. Oops. Let's write this on the other side. Next is 3 and 1, so 3 and 1 would be the same height over here, right? 3 and 1, 3, and then 2 would be up here. Then 4 and 5 would be way up here. What do you see that? We've done this before, right? Have we done this before? We've done this in mid-high math, right? When you had to plot the points, right?
Those were pretty easy.
Okay. Yeah, just go ahead and just put it in, right? There's nothing much to it. Okay. All right, so that's that. And then, okay, in the middle there is a function, okay? A relation, which is what we're talking about. These are all relations. A relation is a function if for each point, each input, there is exactly one output. Okay. So if it's a function, you can have, let's say I mapped it out and I get this, 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 and this. You can have different inputs sharing the same output, which is fine. You're doing a function. What you cannot have is you cannot have from one input, you can't have two separate outputs. Okay, that make sense there? You can have, so different inputs can share the same output. One input can only have one output, though. You cannot have two different outputs there. Okay, that's the difference between a relation and a function. Okay, so example number 3. Tell whether the relation is a function or not. Okay, so let's go to A. The relation at the top of page 401 consisting of the ordered pairs, blah, 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 blah. Okay, so is this a relation or a function? Grace, can you tell me whether this is a relation or a function?
Number example
3A. 3A. So you're looking for each input and making sure it only has one output. Is that true?
No.
Why not?
Because it goes 2, 4, 5, 5, 7.
Well, that's fine. But the problem is that on 5, so you have one input, 5, sometimes goes to 65, sometimes goes to 69, right? So that would be a thing like this we had here, right? Where you had one input going to two different outputs. That cannot happen, I told you, right? So therefore, this is not a function. It's still a relation, but it's not a function. Okay, are we good? Good. On B, it looks like the inputs are 1, 2, 3, 4, and 5, so they're all different anyway, right? There is no sharing of one input going to different outputs, okay? So that would be a function. Okay, all right. So let's look at this graphically and see how this works, okay? So let's go to example number 4. Example number 4A. In the graph below, okay, we use what we call a vertical line test, okay? So on this one here, okay, if I'm going to determine whether this is a function or not, okay, I'm going to look at every input and make sure there's only one point there. Every input has one point, except for here. Right over here, on the vertical line, I have two different dots sharing the same line. You see that on the vertical line, right? So in other words, the same input 3 has two different outputs. And that's a no-no, right? You can't do that on a function. So if it passes the vertical line test, you can call it a function. On this one, it does not pass the vertical line test because on this vertical line, I have more than one point. Does that make sense? Does that make sense? That's what's called the vertical line test. So let's go to example number 4. Look at A. Are there anything where, does this pass the vertical line test? Pastor, what do you think?
No.
Why not?
Or A?
A.
No, there's nothing.
There's nothing that, so it passes, right? Every single point has a vertical line to itself and it's not sharing with a different point. Okay. On B, as you can see, on the 3, you have -2 and 1, which is sharing the vertical line. You're not allowed to do that. So that is not a function, but it is a relation. Okay, all right, are we good? All right, we're done. We're done for the day. Where am I at?